Hey, scholars, this is Mr. Pasillas, your fourth grade STEM teacher, and today we're going to be reviewing some fifth grade standards. It's 5 NBT1, and now we're jumping into exponents. It's pretty awesome, right? It's a new word. Some of you guys may have heard of it. Um, Exponents are refers to the number of times a number is multiplied by itself. So I'm going to show you what that means, okay, and what that looks like. So throughout this lesson, I want you to think of place value and what we've learned so far about place value. As the digit moves from the ones to the tens, it's moving up 10 times more. And as the digit moves to the right, it's going 1/10 of the amount, which is basically just dividing it by 10. Okay, so the number is getting smaller as you divide, and the number is getting bigger as you multiply. So let me show you what that kind of looks like. So let's start off with our favorite number 10, because 10 is a pretty great number. Um, with 10, we know that it relates to place value very well in the sense that um, why we regroup, why we do base 10 problems. So let's go ahead and start with 10. Now, when we know 10 times 10, which is pretty easy, right? 10 times 10 is 100. What I also want you to think about when we're doing exponents is think of patterns. There's lots of patterns in math that help make things easy for us to understand. What we learned in fourth grade was that when we do 10 times 10, all we're basically doing is doing 1 times 1 is 1. And how many zeros do we have? 2, right? And that's the same thing as if we used our place value and we had 110. And if we move that 110 over to the 100 spot, now we have 100. All we did was multiply it by 10. So I want you to keep that understanding. And let's go ahead and what if we had this problem now? 10 times 10 times 10. Well, again, we can still do the same. We can still use the same idea, right? We can do 1 times 1 is really 1, right? And how many zeros do we have? 3 zeros. Okay. So it gets you 1,000. Now, again, that's the same thing if we're thinking place value. We're just thinking as we're moving it over 3 times, right? So if we had 1, and we moved it over 3 times, 1, 2, 3, we have 1,000. So, did you catch Mr. Macia's mistake? 1,000, not 100. So moving over 3 times from the 1 gets you 1,000. Let me erase that right there so it looks right. Very good. So another thing that we're going to learn now, so now we're relating this to exponents, okay? So with exponents, basically instead of doing all that long work, now all we have to do in fifth grade is say 10 to the power of how many zeros do we have? 1, 2, 3, 3. So 10 to the power of 3. And that's what we call an exponent. So it's like saying 10 times 10 times 10. What I want you to not do, and this is a simple mistake some scholars do, is they think that it's 10 times 3, and they're like, 10 to the power of 3 is 30. But that is incorrect, okay? We need to know that um, it's 10 times 10 times 10. So how many times is it multiplied by itself? So it's multiplied by itself three times. You can also think of it as this is 10, so it's 1 with 3 zeros, okay? So let's kind of put this to something a little bit different. Um, we can do well. We know our multiplication facts, right? So when you see problems like this, like 4 times 10 equals 40, right? Because you know that's a multiplication fact. Well, it's the same thing with doing 4 times 1. It's 4, and we have 1 0. Okay, that's the same thing as saying we have 1 4 in the one spot. And because we're multiplying, we know that it's getting bigger, right? So if it's getting bigger by one spot, now it really becomes 4 tens. And we know 4 tens is really 40. So I hope that's clicking right now. If it's not, don't worry about it. We have time to go over this. Plus, you're going to learn it again in fifth grade, right? If it is clicking, then I'm so proud and that's awesome. Um, let's go ahead and try another problem. So if we did something like Let's go even bigger, right? I believe in you guys. 72 times 10. Whoa, that's a bigger number, right? Instead of us having to do a big area model or do something like that, all we have to do is say 72 times 1 is 72. And how many zeros do we have? 1, right? So your answer is 720. And you can do math that fast. So, and even tell your parents, what's 72 times 10? And see if they can get 720. See if they can do math just as fast as you. So, um, where this changes a little bit is, or it doesn't change a little bit. It actually, it's the same thing, but you guys look at it differently, and that's applying it to decimals. Okay, so let's go ahead and apply this to decimals, and let's say we have, actually before we even go to decimals, let's go to exponents. So multiplying a number like 7 times 10 to the power of 2. Okay, did you guys remember what 10 to the power 2 is really? Yeah, it's just 10 times 10, which 10 times 10 we know is what? 100. And we know that 100 has two zeros. So basically it's just 1 with two zeros, right? Do we know what 7 times 100 is? So if 10 to the power 2 really means 100, it's just 7 times 100. And we know that 7 times 1 is 7 with two zeros, right? That's how easy it is to do that problem. Let's try another one together, guys. Let's go with 12 times 10 to the power of 2. Okay, right now I want you to pause this video and see if you can do this on your own. Hopefully you guys paused your video and you solved your answer and that you're being truthful. And let's see if you guys got your answer right. So again, we can just do 12 times 1, and that's 12, right? How many zeros are we going to add to it? 2. And that's how easy doing this type of problem is. Imagine that, 12 times 10 to the power of 2. Whoa, that sounds like a crazy big problem, right? But did you see how easy we solved it? It's so quick and so fast. But again, you have to remember the reason why we add these zeros, and that's because of the place value, okay? Now let's apply this to decimals. So if we had 2.1 times 10, we know that this number, is it going to get bigger or smaller? Yeah, it's going to get bigger. The value is going to increase because we're multiplying. When we multiply, we get more. And so let's go ahead, and if we multiply it, we had this in here, we have 2.1. We multiply it by 10, we know it's moving over how many place value spots? Yeah, one place value spot because it's being multiplied by 10. So we can plug this in now. We can move this over, move this 2 over, and now it becomes 21. Okay, so again, what we're really doing is just moving this decimal over, plugging it right there, and now instead of it being 2.1, it really becomes 21. Let's kind of look at it. Let me see your other problems that you have. This is some problems that you have on your sheet. These look pretty easy, right? So if we were to do this one, what would this look like if we were to do 10 to the power of what? So it'd be 10, and then we should count our zeros, right? 1, 2, 3, 4, 4 zeros. So it'd be 10 to the power of 4. Down here is where you might have some problems that you have to think about, and this is probably going to be your harder problem right here. 4.025 times 10 to the power of 3. Let's go ahead and do that one together. Um, we'll put it right here. So 4.025 times 10 to the power of 3. Okay, now we have to ask ourselves, is our number going to get bigger or smaller? Yeah, we know it's going to get bigger because we're multiplying it, right? But how many times bigger is it going to get? Let's look at our exponent. It's going to get 3 times bigger, right? Well, we can move this, so it's 10 times 10 times 10, right? So we know that we're going to move it 3 place value spots, okay? If we move this decimal over here, is the number getting bigger or smaller? Yeah, it would be getting smaller, right? So we have to move our decimal over 3 spots. 1, 2, 3, and now our new number is really just 4,025. Okay. You can leave your decimal there. It's not going to make a difference. You can just put it right there, or you can leave it off because we know that it's a whole number and there's no fraction left over. So that's as easy as we can do our problems. I know it's going to sound a little bit complicated, but I want you guys to rewatch this video if you need to, or make sure that you're joining one of our office hours. You now have several different ways to go over math. So reach out to us and hope you guys do a great job with this. See you later. Bye.